Good morning, guys. So I'm going to go through the Kirchoff notes with you guys right now. Let me take a look here. I'll go through the PowerPoint presentation. Okay. So Kirchhoff's law basically states that in any junction or any intersection, the current going in must equal the current going out. All right, so if you look over here on this picture to the right, we have this current I1. It has 11 amps. All right, when it hits this junction, 11 amps are going into this point A. And if we look at the two currents going out, 7 amps in I2, 4 amps in I3. If we add 7 and 4 together, that gives us 11 amps, right? And that shows that Kirchhoff's junction rule is working here. 11 amps went in to A, and then 11 amps went out of A. Just the difference is in the first part, it goes in as one current, and part two, it leaves as two different currents, but the total value still remains the same. So here we have this spot. So there's this junction right in the middle of these arrows. So we want to solve for X. How many amps is in this X arrow? So we have to think about it, and we're going to kind of set up as a little math problem here. So I'm looking for okay. So if we look going into this junction, there are 4 amps. That's going in. Okay. Also going into this junction are 2 amps. And also going into this junction are X amps. So plus X. And then leaving the junction is 11. So we can say that then minus 11 and then equals 0.
What are you doing? You're doing here.
We're recording something for my kids, buddy. All right, so if we solve for X, all right, so again, 4 amps going in, 2 amps going in, X amps going in, 11 amps going out, so it's minus, and then it equals 0 because all the current going in must equal all the current going out. We can rearrange it as 6 plus X equals 11. And then what does X equal? X would be 5 amps. All right, so that's how we do the first one. So again, current going in equals current going out. All right. All right, so I'm trying to find erase all. Okay. All right, let's look at this one. Solve for X and Y. So same thing again. So going into this first junction is 3 amps and Y amps. Well, these two things must add together to give you X. Travels through this X. And then this junction splits into 3 parts, 4, 2, and 5. So we're going to work backwards. So what we're going to do is we are going to actually kind of do it like this. So we know that we're going to look at this spot right here. So what's going into this spot? X. And then what's leaving it? 4, 2, and 5. Right? The X went into here. The 4, 2, and 5 leave. We say that equals 0. Right? So okay, bud, 1 sec. All right, so 1 second. All right, so the X had the current going in and the 4, 2, and 5 going out. So if we solve for X, if we bring the 4, 2, and 5 to the side, we find out X is 11 amps. Okay, so now we can say, hey, X is not X. We can write it as 11. And now we can say the same thing. If we look at this junction right here, 3 plus y equals 11. Because really we say 3 plus y minus 11. So when we solve for y, we get 8. Okay, buddy. So X is 11 amps and Y is 8 amps. Okay. So that's the first two. Let's look at the next one. All right, so write an equation for the current at each junction. So this one is the next step up. We're gonna have to actually figure out what current's going in and what current's going out. So to do this one, we're gonna actually kind of look at it like this. The current is gonna leave this battery and travel this way. So let's write down what we've got. Okay, so this current is gonna be called I1, and it's going this way. Now, when it hits A, it has to change. There's going to be a current going down. There's going to be a current going back to the, terrible, to the left. We'll call this one I2, and this is I3. I3 continues all the way through the circuit. Going on, so this is still I3. And I2 keeps going this way until it gets to point B. Right, so I1 went down, hits A. At A, I1 splits into I2, which goes to the left, and I3, which goes down and around. Then when it gets back up to B, up here, what goes back around? I1. So we wanted to write an equation for the current at each junction. Okay, we could say for A, what's happening at A? Well, what current's entering A? I1. And what current's leaving A? I2, right? Going this way. And I3. Right? And then if we do B, what's happening at B? Let's be the exact opposite. At B, who's entering it? I2 and I3. And who's leaving it? I1. So in this problem, we made our three currents, okay? We just picked the battery, we went around in a circle from the battery. We called the first current I1. When it hits its first junction, it must split. It split into I2 and I3. If we trace I2, it would stay as I2. Goes through and it gets back to this junction. So I2 is just this spot right here. This is all I2. I3 ended up going down and it keeps going around and around and around and around and around and around. And I3 also stays good. When both things meet it back at B, we know they have to form some new current, and that new current is what goes back to the battery. Well, the current that left the battery is I1, so they must form I1 again, and that's how we got our equations. All right, so let's look at this one. Write equation for the current at each junction. So we have 4 junctions, A, B, C, and D. Right, so we're the same idea again. Right, so let's pick a color. We'll do green. Okay, so the first current leaves here and goes this way. This is I1. When I1 hits A, we're going to get an I2. And we're going to get something here that keeps going this way. We'll call this I3. When I3 hits junction B, it's going to split. We'll have something going down. We'll call that I4. Now something going to the right, and we're going to call that I5. Okay, so one left the battery, hits A. It splits into 2 currents, I2 and I3, right? Then it gets to B. I3 splits again into I4 and I5. So now we're going to go back around. Okay, at D, I5 heads back into D, but so does I4. So what would be going this way? We would call this I3. It's going this way. And if we at C, it's the opposite of A. So at C, I1 went in and 2 and 3 went out. Well, at A, I1 goes in and 2 and 3 goes out. At C, 2 and 3 go in and I1 goes out. So those are our currents. Okay? And this I5, by the way, goes all the way in a circle. So now if we want to do one for each one, so for A, okay, A is I1 goes in and I2 and I3 go out. Okay. At B, I3 goes in, but I4 and I5 go out. Oh my, that last one was terrible. That is the worst 5 in the world. Ugh. Erase that. Jacked up 5. All right. Okay. At D, I4 and I5 enter D, while I3 leaves. Okay, so this is equal to 0, 2. And then at C, last one, okay, I2 and I3 enter, and I1 leaves. All right. So that's it. We do all 4. Okay. Same idea again. Label your currents. Okay. Every junction, there's a split. Make sure at the end of a junction they can add back together, and then we'll end up kind of going from there. So you guys have the first 4. All right. So now, if we go over here, all right, you have one more problem, and it says try this on your own, and that's in your notes. So now you guys can try that last one out on your own. All right. If you guys have any questions at all right, shoot me a reminder, let me know, and have a good day, guys.